Hi, everybody. Welcome back to the Shuko Math Practice Lab, Learning Through Practicing. And we are in the practice set number 2 here. So in this practice set, we're going to take a look, how can I use the first derivative to determine a function is increasing or decreasing. You know, if you remember on the practice set number 1, when we look at function increasing, decreasing, you know, the practice set number 1 is focused on like the different graphs. So if they give you f of x or f prime x, so how do I use that to determine a function is increasing or decreasing in certain intervals here. So in this practice, instead of giving the graph, then we're going to give you the functions here. So like then for each function, how do I determine which interval is increasing or decreasing? So here, you know, are the 6 problems today we're going to practice in this practice set. And so each problem will show you some different things. We need to be careful about it. Okay, so now if you want to pause your video right now, would be a good place to pause it and write down the problems and try to practice those problems by yourself first, and to see, you know, you'll be able to get some of them. And then after you finish, then resume the video and come back and we can work on those problems together. At the same time, you can check your answers. Okay? So now it's a good time to pause the videos, and I'm going to go to the whiteboard, and then when you finish, you resume the video and we can check the answers together here. Okay? Okay, so now let's take a look. And if you still remember, let's do a brief review for the f of x increasing or decreasing. So we know the first derivative test, right? So like, you know, like if a function is here, so let's just take a look at what we did before. So for the f of x is here, right? So if you have a functions here, like this one. Okay, so if this is my f of x, and if here, let's say here, this is a, all right? So I know these segments here, right? So these segments, when the x increase, what happened? So these segments, we know this is the increasing, right? So f of x is increasing on these segments. And we know, you know, the derivative really is the slope of your tangent line. So if you take the tangent lines here, right? So if you take the tangent line on these little segments here, so what happens here? The slope of the tangent line is always what? It's always positive, right? So then the same way you go back to the other side, this side here, right? So this side here, and we know this function is decreasing. So the same way, if you just take the tangent line along this curves here. So what happens here? You see the tangent lines here is the slope of the tangent lines here. It's always like negatives here. So that's why we said, you know, if f prime x is, right? If f prime x is greater than 0 on a certain interval, then what happens here? So I know the f of x is what? Is an increasing point. It's increasing in that intervals, right? So at the same time, if the f of x is less than 0, then what happens here? Then we know the f of x is what? Is a decreasing, right? So it's a decreasing on that intervals here. And then, like in here, you see at this point here, right? At this point, this is the where, you know, the function change from the increasing to decreasing. So like in here, as you see, what happens here? You know, the derivatives here is equal to what? Because this is the tangent line, is parallel, right? So what is the slope here? So the slope here is what? Slope here is 0, right? That means this is f prime x equal to 0. So this is somehow called as the critical numbers. So that means in here, for these curves here, you know this one gives you local max, right? Because it's kind of the increasing to the highest point and then decreasing here, all right? So now this is a brief review. So make sure so we know this, right? So if it's increasing, I'm going to have a positive slope, right? So it's f prime x has to be greater than 0. And then if f prime x is less than 0, that means I'm going to have negative slope, and that means fx is decreasing. Okay, so now let's take a look at our problems here. And so I hope that you already finished the most of them. Okay, so the first one's here, the way we say, okay, so the first, I assume you still remember some basic integration formula, right? So the f of x is 2x cubed minus 9x squared plus 12x. So the derivative is 3 times 2 is what? It's 6x squared minus 18x plus what? Plus 12, right? So I want to see the f prime x is greater than 0 or less than 0. So typical, the way we do it, we cannot factor. So here I see I can factor the 6 out first, right? So this is 6x plus 2. Okay, and then I can do, this is 6, then this is x minus 2, x minus 1, right? So now, after that, because I know the turning point, so I will set, right? So we will set the f prime x equal to 0, and then we want to solve for x, right? Okay, so if x prime x equal to 0, that means x minus 2 equal to 0, or x minus 1 equal to 0, correct? Okay, so that means x minus 2 equal to 0 or x minus 1 equal to 0. So I know x equal to 2 and x equal to 1. Okay, so those are my critical points here. Okay, so now how do I determine this increasing, decreasing? This is a typical what I would do. So you put it into a number lines here. Okay, so now you put the 1s here and then you put the 2s here, right? And then in here you put your f prime x here. Okay, so the f prime x is equal to the 6x minus 2, x minus 1, right? So the way we decide, we say, okay, now you choose any points, right? You choose any points on the, so like in here, let's say here, so basically you divide this line into like 3 different intervals. So you choose any points in the interval, then you put it into the f prime x to see, you get a negative or positive. So let's take a look here. So if I choose zeros here, so if I choose 0, so it's 0 minus 2 is negative 2, so it's minus, right? So what I have for this one, so minus times minus, I have what? I have a positive, right? Now for these ones here, for this interval, you choose anything in between. If I choose 1.5, so 1.5 minus 2 is negative. 1.5 minus 1 is positive. So it's minus positive. So what is here? I have negatives, right? Now the third one's here, you do the same way. You choose any number, you put it into f prime x. I choose 3. So 3 minus 2 is a positive. And 3 minus 1 is a positive. So it's a positive or positive. So what do you have here? You have positives, right? So remember, right, we say f prime x. So here, if you want, this is f prime x, right? So we say the f prime x is positive and your function is increasing. So I know my function. So this is my functions, right? So my function is increasing and now is decreasing, right? Now here is increasing again. So that means my function is increasing, and now hit x equal to 1, then I start to decreasing, right? So I know that x equal to 1, right? So this is my critical point, right? And what is in here, I'm increasing and decreasing. What I have here, I have a local max, right? Because this graph is something like this, right? That's why you have a local max here. Okay, and then now let's take a look. And this one's here, this is x equal to 2. So it's going down and then going up. So I know here x equal to 2, I have a what here? I have a local what? Local minimums here, right? Okay, so now this is how I can write it, right? So now finally I will say the f of x increasing, right? So it's from the negative infinity to 1 and what? 2 to the positive infinity, right? And the f of x decreasing is from what? From 1 to 2. And my critical point, right? So the critical point when the x equal to 1, we have x equal to 1s, right? So now you substitute to the function. When you substitute to functions here, you will get the 2's here, right? Then also the critical point x equal to 2, you substitute the function, this is 1. So how do you get 2's here? That means f of 1's, right? And this is f of 2. Right, so you just substitute to whatever the your functions here to get the function value. So those are my critical points here, and for those critical points, right? Like we say, this one's here is what? This is local what? Is local max, and what is here? This is local mins, right? Okay, so that's pretty straightforward. Okay, now let's take a look. After we practice 6 of them, I think you'll be very good at it, right? Okay, so now the f of x equal to the x over x squared, right? So we do the same thing. So we do the f prime x. So the f prime x, I need to use the quotient rules, right? So quotient rule will tell you, you square the bottom. It's going to review about the quotient rule. You square the bottom, then you hold the bottom. So the bottom is x squared plus 1. Then you take the derivative about the top. So x, you take the derivative is 1, right? And then you hold the top, so it's x, you take the derivative of the bottom. So it's x squared plus 1, you take the derivative is what? It's 2x, right? Okay, so now let's simplify this a little bit. So this is x squared plus 1 to the square. So this is what? This is x squared plus 1 minus 2x squared. Okay, so now in here, I will have x squared plus 1 to the square. Then this is 1 minus x squared, right? Because you have x squared, the negative 2x. And now the same way, I what? I factor. So this is would be 1 minus x and 1 plus x. So the almost the same procedure. So you set f prime x equal to 0. And when you set f prime x equal to 0, I know the denominator can never be 0. So that means 1 minus x. And that's basically, that means 1 minus x and 1 plus x has to be equal to 0, right? So the numerator has to be equal to 0. So 1 minus x has to be equal to 0. So x equal to 1. Then 1 plus x has to be equal to 0. X equal to negative 1. Okay, so what is the next? Just like we talked before, I put it into the the real number line, then I marked it here. So those are my critical points. So I marked the negative 1 and the 1. And then I put my f prime x here. So I can see, so this is 1 minus x, 1 plus x, and x squared plus 1 to the square. Okay, so now let's take a look here. If I take any number less than negative 1, let's say the negative 2 here, right? So the negative 2, the bottom is always positive, right? So this one here, I don't need to care about because numerator is square, so it's always positive. So if I put a negative 2, so this will be 1 minus negative 2, so it's a positive. So it's a positive, it's negative. So what is this intervals here? It's negatives, right? Okay, now the next one's here. I choose any number inside. I choose 0. So 1 minus 0 is what? It's positives, right? So 1 plus 0 is a positive. So that's good. So this one is a positive, right? And then now I choose like a 2. So 1 minus 2 is what? 1 minus 2 is a negative. 1 plus 2 is a positive. So positive times negative is what? It's negative, right? So remember, this is f prime x. Okay, so after you get your f prime x here, then I know my f of x, right? So remember the f of x, negative is decreasing, positive is increasing, negative again is decreasing, right? So now I know that x is equal to what? X equal to negative 1. And this is x equal to 1 because this is decreasing and increasing, right? So you're going down and going up. So this one is local what? Local means here, right? And this one here is going up and then going down. So this is what? This is local max. All right. Okay. So now we can write it. So I know the f of x, right? So here f of x increasing. In where is increasing on negative 1 to 1. Then f of x, what? Decreasing. The decreasing on where? The decreasing is from negative infinity to negative 1. And what? 1 to what? So decreasing and 1 to infinity is correct. Okay, so now the critical point. Okay, so will be x equal to the negative 1 and the f of negative 1. And also will be x equal to 1, f of the 1. So you need to plug the value. So this is negative 1. And if you plug back to your f of functions, so this will give you negative 1/2. And then here is 1, so give you positive 1/2, right? And so we know just from here, this one's here, this is local minimum point. And this is what? It's a local maximum point, right? So the procedure is the same. You take a look at the derivative, you set the first derivative equal to 0, you graph it, then you identify it, right? Okay, so now let's take a look at next problems here. And okay, so next problem is cosine square x and the true sine, x here. So here they do give us limitation. So they said x has to be between 0 and 2 pi. Okay, so now the same way, the same old, right? So I take a look at f prime x. So here, this is where you need to be very familiar with your derivatives, right? So cosine square x, you use the power rule first. So here is 2 cosine x. Then don't forget the chain rule. You need to take derivative of cosine, it will give you a negative sign. Then minus 2, what is the sine's derivative? It's a cosine, right? So it's a cosine x here. Okay, then try to combine the factor to see if we can get any idea. So here, 2 cosine x, oh, that's good choice, right? I can take the cosine x out. And then the cosine, what it has a negative. Let's take the negative out also. Then here, this have sine x what? Plus 1, right? And then we set equal to what? Set equal to 0. So that means cosine x equal to 0 or sine x plus 1 equal to 0. That means sine x equal to what? Negative 1, right? So now you need to, go back to your, your unit circles here. So, or you can do like this. Cosine is like this, right? Cosine is here. So where cosine gets zeros here? Okay, so it's a pi over 2. So this is a pi over 2, and this is a what? 3 pi over 2, right? Okay, so I know when the cosine x equal to 0, I can have x equal to pi over 2 and the 3 pi over what? 3 pi over 2. Then the same way for the sine is this, right? So the sine is equal to the -1. So it's at this point here, right? So sine equal to the -1. So what is this one? It's 3 pi over 2. All right, so when the sine x equal to -1, so I get x equal to what? 3 pi over 2. Okay, so good. And after that, so the same old, right? Let's put it on the line, number lines here, okay? And then here, I put this one is pi over 2. And then this one here is 3 pi over 2. Now I'm going to put my f prime x here, right? So f prime x, I have a negative sign in the front, right? So it's 2 cosine x sine x plus 1. Okay. So now, okay, so for anything less than pi over 2, so, I always have this negative sign, so I'm going to put this negative sign for all these three. Okay, so anything less than pi over 2, from 0 to pi over 2, cosine is positive, right? So cosine is positive. Then the sines here, sine x plus 1, because the sine value is always less than or equal to 1. So when you plus 1, doesn't matter what the value of here, these terms are always positive, so it's positive. So what happened to these intervals here? This will be negatives, right? Okay, now let's take a look at the next ones here. So somewhere between pi over 2 to the 3 pi over 2, as you can see, the cosine is always negative, so it's negative. But the sine again, the last terms here is always positive, right? So the negative, negative, positive. So what is here? So this is the positives, right? Okay, so now the last ones here, for the 3 pi over 2 to the 2 pi, what happened to cosines here? Cosine be positive. What happened to sines here? Sines here is what? Sines here will be from the 3 pi over 2 to the 2 pi. So this will be sine 3 pi over 2 to the 2 pi. So this will be negatives, right? Okay, so this will be negatives. And now you can set a negative, negative, positive. So what is here? So this is positives, right? So it's negative and the 3 pi over 2. So cosine is positive, and here is 3 pi over 2. Okay, so this is f of what? This is f of x, f prime x, right? Okay, now I'm going to, so this is decreasing and what? And this is decreasing, and this is increasing, and this is what? Increasing here, right? So that's why this is my f of x here. Okay, and so, sorry, here, I think I made a mistake here. Sorry, here. Okay, so I'm not careful here, all right? So here, because we just mentioned, we said, we said here, the whole this term, sine, doesn't matter. It's always going to be positive because sine is always less than 1. So whatever you add 1 is positive. So this is positive. So that's why this one is negatives here, right? If negative here, then this one is going down, right? Okay, so that's what is the function behaves. So in here, we can say that x equal to pi over 2 is what is a critical point, and x equal to the 3 pi over 2 is a critical point. So this is going down, going up. So this will be what? Local mean. And this is going up, going down. So this is what? Local max here. Okay, so now let's try to write it. So we know the f of x is here increasing. Is from where to where? Is pi over 2 to the 3 pi over 2. Then f of x decreasing is from where? From the 0 to the pi over 2. And because in here we specifically defined these functions from 0 to 2 pi, and decreasing is here, right? So it's from 3 pi over 2 to the 2 pi. And then we have our critical point. Okay, so the first critical point is pi over 2. Then you put the f of pi over 2. Then the second one is here, the x equal to the 3 pi, oh, I shouldn't write that. So the x equal to the 3 pi over 2. Then you have the f of the 3 pi over 2 here. Now you substitute the value. So this is pi over 2. And the f of pi over 2, you get this is negative 2. And then this one's here, you will get 3 pi over 2. F of the 3 pi over 2, you will get its 2 here. So I have two critical points here. One is, so this one's here is what? Is local mean, and this one's here is local max here. Yeah, so be careful when you try to put the positive and negatives here. A while ago, I did not pay attention, so I get it wrong here. So be careful for that. Okay, so now the next one's here. Let's take a look at this one's here. F of x e to the 2x plus e to the negative x. Same more, and I choose the different type of the function. I just want to get the feeling for the different function. How do we solve it, right? Okay, so same ways here. Let's take a look at f prime x is here. So we know the exponential function, you take the derivative, will be itself. So it's e to x. Don't forget the chain rule to here, right? So here, this is 2. And then plus e to the negative x. Then don't forget the chain rules here, negative 1. So what do we have here? So we have 2 to the e to the 2x, right? Minus e to the negative x here. Now we set this one equal to 0. So the reason why I put this problem is because I want you to know when you're dealing with exponential. So typical, the way you want to factor. So we say, okay, we want to factor lowers the terms out. So that means I do the e to the negative x. Okay, so if e to the negative x, so this is 2, right? Because this is 2x, I take one negative. So what I need to have, I have a 3x, correct? So I have 3x, this is a minus 1. Then I will let it equal to what? I will let it equal to 0, right? So now I will set f prime x equal to 0. That means, you know, the e to, so this will be e to the x, then the 2e 3x minus 1 equal to 0. And I know the denominator cannot be equal to 0. So what I have here, I have 2 to 3 e3x minus 1 equal to 0. So that means e the 3x equal to the 1/2. And natural log both sides. So the 3x equal to the natural log 1/2 divided by 3. So x is equal to 3, the natural log 1/2, right? And put it into the calculator, approximately this number is negative 0.23. Okay, so same old, we do the same thing and put into number lines here. So for this number line, so here this is the critical point. So it's this natural log 2 over natural log 1/2, right? So this is natural log 1/2 over 3, right? So this is equal to close to, approximate to negative 0.23, right? So you say this is my f prime x. So put your f prime x here. So the e, the 3x minus 1, ex here. All right. So now, because I know the denominator can never be 0, so I choose any number. So I choose any number like, okay, so the less than negative 0.23, then I put it into here, if less than negative 0.23, so the 2 to the e to 3x minus 1 will give me a negative numbers, right? I only have one negative numbers here. Then if I choose anything greater than 0, right? So I will have a what? I have a positive. So if you choose 0, it's greater than negative 0.23, so it will be 2 minus 1, so it's positive. So this is what happens. So this is the, so as I know, then the whole function, so the whole derivative, this is negative, right? So this is positive. Then this is, we said this is f prime x, and to be consistent, then the f of x here will just be what? Decreasing and increasing here, right? So the x equal to the natural log 1/2 over 3. This is my what point? Critical point, right? Okay, so now let's try to write it. So I will say the f of x is what? Increasing, right? In where? F of x is increasing is from the 3 to the natural log 1/2 to where? To infinity. Then f of x decreasing from where? From the negative infinity to what? To the natural log 1/2 to the 3, right? So the critical points here, just the same thing. So the critical points here will just be what? Will just be like the x equal to the natural log 1/2 to the 3. Then you put this number into there. So it's f of the natural log 1/2 to the 3. Then you use your calculator. You will get like a close number. This is natural log 2 1/2 over 3. And then in here, this is close to like 1.89, right? So this is just approximate to 1.89, but we know this is what? This is local. So this is going down and going up, right? So this is going down and going up, right? So it's like going down, going up, right? So what type of the here? We have what? We have local means here, right? Okay. So now you know how to dealing with the function if they have exponentials here, right? Now let's take a look at the next ones here. Okay, so next one, first one's here, this is f of x equal to the x squared, the natural log x, right? So the first things you need to know, because natural log cannot be less, cannot be less than 0. So first things I know the domains here. The domains here is from 0 to infinity here, so we need to be careful, cannot include the zeros here. Okay, so now let's take a look at f prime x. All right, so the f prime x here, so what rule I'm going to use? I have x squared and the natural log x, so what rule? Product rules, right? So I have, this is 2x times natural log x plus x squared, natural log x, the derivative is what? 1 over x. Okay, so good. So this is 2x natural log x plus x. That's right. Good job. So what do we do? Set it equal to what? 0. So we have a 2x natural log x plus x equal to 0. Factor. Right, so this is 2 natural log x plus 1 equal to 0. So the 2 natural log x plus 1 equal to 0. So I know x equal to 0 or 2 natural log x plus 1 equal to 0. And in here, I know x cannot be equal to 0. Why? Because the domains, right? So domain not include 0. All right, so now this one here is a 2 natural log x plus 1. So it's a 2 natural log x equal to the negative 1. So natural log x equal to negative 1/2. You take exponential both sides, so it's a negative 1/2. And then here, this is 1 over square root of the e's, right? Okay, so now after that, do the same thing, put it into a number line. Okay. So number lines here, so this is 1 over square root of the e's here. So then you put your f prime x here. The f prime x is x and the 2 natural log x plus 1 here, right? Okay, so now let's take a look. For anything is less than 1 over square root of the e's here. So like if you say natural log x, if you put x is equal to, this is square roots, so It's like 1/5, right? 1/5. Okay, so then try it. So you will find out this is positive and negative, right? Okay, so I know the overall here, this number is going to be negative. Now you choose anything greater than that. So let's say we choose 1. 1 is greater than, so this is a positive, positive. So I have a positive, right? So this is my f prime x here. Now the same way, let's take a look at f of x, right? So you can see I'm very consistent with all the problems we did, right? So if you do this, you won't get confused and you won't mix up. So this is going down, this is going up. So the x equal to the 1/e. So here this is going down, going up. So what I have a local what? Local means here. Did you see here? It's every problem is very, very mechanical and routine. Okay, so I know the increasing. Okay, so we say f of x increasing where? Here, right? So it's 1/e the square root, go to what? Infinity. Then f of x decreasing from where? From 0 to 1/e, right? Because the natural log, so I know the domains here, even they did not give us, so I know the domain of natural log is 0 to infinity, right? So now let's take a look. So my critical point. Okay, so basically just 1 square root of the e, then you put this number into the functions here. So I kind of got it. So this will just be 1 square root of the e's here. So these numbers here is -1/2 and times e here. Okay, so you can use your calculator to do that, and this number is kind of like approximately to the 0.18, right? So it's kind of like equal to 0.18. Okay, did you get that? Okay, so I think this is so this will be -0.18. Okay, yeah, so don't forget the negative signs here. Okay, so how do we do natural log? So the reason why I want to put the natural logs here is because, be careful about the domains, right? Okay, so let's take a look at our last problems here. So f of x, the x squared minus x natural log. Every time I see a natural log, but here I immediately know the domains here. We need to be careful. This is 0 to infinity, right? Now we can do the same thing. Okay, so let's try. So this is f prime x. So the derivative here, this is 2x minus 1 minus natural log is 1/x, right? So for those type of the problem, what you do here, you find a common denominator, so you combine it. So this is x. So 2x for the common denominator, you will have what? 2x squared, right? Minus x minus 1, correct? Okay, so you set this one equal to 0. So the f prime equal to 0, I know the denominator cannot be equal to 0. That means 2x squared minus x minus 1 has to be equal to 0, correct? Okay, now you do factor. So when you factor, this will be 2x plus 1 times x minus 1 equal to 0 after you factor. That means 2x plus 1 has to be equal to 0, or x minus 1 has to be equal to 0. So this one will equal to x equal to -1/2. This one is x equal to 1. As you see, x here cannot be equal to 1/2, right? Because it's outside what? Outside my domains here. That's what I want you to be careful, right? So you need to take a look, or you cannot just put a critical point there because it's outside the domain. Now here, the x equal to what? Equal to 1 here, right? So this is the f prime x equal to 0. And then also we have, okay, so the f prime x not defined. is at the x equal to what? At x equal to 0, right? Because you have a denominator. So that's why in here, what we try to do, so let's see here. Okay, so here now, you can put the 0 here because this is a domains here, right? So now here is 1s here. Now you put the values inside. Okay, so now let's take a look here. For anything from 0 to 1, so I know, because the domain is from 0 to infinity, so this ones here is always positives, right? Okay, so anything between the 0 and the 1, you put it into this equations here. So what you're going to have, you're going to have a positive negatives, right? So the overall here is negative. Then if you put anything greater than 1, so you're going to have a positive. So what do you have? You have a positives, right? So this is f prime x. Now the same way, I have f of x is here. So what happened to here? S is decreasing, f is increasing. So x equal to 1, here is my critical point. Okay, so going down, going up. So what I have? Local what? Local means, right? Good job. So now let's try to write it. So we know the f of x increasing, right? So the increasing is from where? 1 to infinity. F of x decreasing is from where? Domain. Be careful, right? So it's a domain from the 0 to what? To 1, right? And then the critical point is the f of 1 and the f of 1 and the f of 1, right? So you substitute the 1 into the f of x is 1 minus 1 minus, so what is 0 here? So I know what is this one here. This is our local means here, all right? And that's it. We did 6 problems, and I think from all these 6, the methods is very, very consistent, right? So what you try to do here, you take a first derivative, right? And you set the first derivative equal to 0, then you factor the first derivative, and then to find out what numbers of x make the first derivative equal to 0, then you put it into the number lines, and then you decide the intervals divided by those points, which interval be positive, which interval be negative, right? And then we know if the f prime x is negative, then the function is decreasing, f prime x is positive, is increasing. Also, based on the pattern, you can decide that the critical point is local mass or local means here, okay? So that's it. That is this practice set. It's a little long, but I just want to make sure you learn that. Also, the last 2 problems, be very careful. It's involved the natural log x, so you need to be careful about what is the domain. We need to be careful about that. All right, so don't forget practicing, right? That's very important to get better in the math. If you like this video and you think it's helpful, feel free to subscribe to my channel. And if you still have some problems, yes, some questions, feel free to leave me a comment and I will answer your questions here. Okay, so it's so nice to talk to you, and have a good day. And next video, we're going to talk about concavities here. So looking forward to talk to you again. Okay, have a good day and bye.